Can you all see my screen?
Yes, sir.
Yes, sir.
Okay. So today we are going to start string algorithms. So I am assuming that everybody of you here knows what is a string. It's basically a vector of characters. So it's basically a vector where the data type of each element is a character, and you can like perform normal operations what you do on a vector on a string. Also, you can like reverse a vector. Reverse a string. You can like add two strings together using the plus operator. You can like find the character at any index by using s of s at I like you do in vector or arrays. So we will be seeing today some algorithms on strings type of data types. Okay, so first of all, before we start, can anyone tell me what's the complexity of comparing two strings? Like if you use the equal to compare operator or the less than operator, what is the complexity of comparing any two strings?
O of
Wow.
length.
Yes, it's O of n. Actually, I've seen many people making this mistake. They usually think that comparison is O of 1, but no, string comparison is O of n type. Okay. And similarly, if you are adding two strings, the complexity of that is also O of length of first string plus O of length of the second string. But if you are using the plus equal to operator, um, then the complexity of that thing is only the length of the second string that you are adding. For example, if I write s equal to s plus t, the complexity of this thing is equal to um, O of, just a minute, this is O of length of s plus length of t. Okay, but if I write s plus equal to t, it has a complexity O of length of t only. Okay, so this is also a common mistake that many people think that this is equivalent to this, but no. Actually, this is not equivalent to this. This has far more complexity, especially if your s is a big string and t is a small string. Then this creates a lot of difference. Okay, so this is just some basic things about string, and now let's start with the KMP algorithm. So uh, KMP algorithm, or also known as a prefix function. So it's by definition, prefix function is an array such that EI generally represent the just a minute. Sorry. Yeah. So basically, prefix function is basically an array in which prefix of I is the length of the largest prefix, which is also a suffix of the string. Let me say substring s of 0 to s of I. Now, uh, let me just explain you with an example. What does this actually mean? So suppose if I give you a string, let's say ABC, AB, and then C. Okay, so uh, okay, yeah. So by definition, prefix function is basically an array. So here it will be an array of length 6 because our string has a length 6, and prefix at I will represent the length of the largest prefix, which is also the suffix of the substring s of 0 to s of I. Now, what this substring s of 0 to s of I means, basically for I equal to 0, you are just considering the string A. Okay. So for I equal to 0, it's just the string A. For I equal to 1, it is the string AB. For I equal to 2, it will be the string ABC and so on. Okay. Now, this is what this S of 0 to S of I will represent. And this P of I, the pi of I, which is also the prefix function at I, this will be the length of the longest prefix of this string. Longest proper prefix, let me say, the largest proper prefix. Okay, by proper prefix I mean not the whole string, because also the if you take the whole string, that will be a prefix also, that will be a suffix also, so we are not considering that thing. We are considering only proper prefix, which is not the whole string, and also which is not empty. Okay, so we are trying to find the length of the longest proper prefix, which is also suffix of the string. So basically here you have no proper prefix, so uh, for this thing, pi at 0 should be equal to 0. Next up, for this, here you have just only one proper prefix, which is a, but this is not a suffix. This a is not a suffix of this string. So again, pi of 1, that will also be equal to 0. Here, for example, again, you have two proper prefixes, a and ab. These are proper prefixes, but these are not suffix. None of them is a suffix. So for pi of 2 also, you have 0. Means there is no such prefix. Okay, now let's see one more. For I equal to 3, you have the string ABCA. Now notice one thing. You have three proper prefixes, A, AB, and AC. ABC. Now, ABC is not a suffix, AB is not a suffix, but A is a suffix. Okay, A is a suffix of the string also. So here the length of the longest uh, prefix, which is also a suffix, that should be equal to 1. Okay, because you have A here. Again, for I equal to 4, you have the string AB, and here you can see that A is proper prefix. AB is a proper, like you have many proper prefixes, but in this case, AB, this proper prefix AB is also a proper suffix of the string AB. So here you have pi of 4 equal to 2, which is the length of this AB. And similarly for I equal to 5, you have ABC, and in this case you will get pi of 5 equal to 3. Okay, so this is what the definition of this prefix function is. So just tell me one thing, is this clear? And you can just write in the chat if the definition of prefix function is clear or not. Okay, fine. So now the task here is to find this value, uh, this array pi. Okay, so um, can anyone just start with the most basic approach? Like, can you find up something with like an O of n cube approach, where n is the length of the string? So anyone, like the most basic n cube approach here?
For all substring, we will find the like we start from one and we match it with last. Where it non-matches, that up to that will be pi of I.
Sorry,
So,
we will start with the. Can you just repeat?
so for we will take all these strings, substrings,
Yeah.
uh, like ABC.
Yes. Yes. Okay. Then,
Then we compare first with last index. Like A will be compared with
can you say for this string I equal to 4? How
yes,
you are
sir.
going to do?
Uh, then we assume that for each length, each possible length, we will check that this is true or not.
Okay. Yeah. Basically, that's the most basic approach. So what you will do, you will just simply iterate over it. I equal to 0 to I less than n. So for each of these values, you will separately consider these substrings. And what you will do, you will consider what's the length possible. So for int j equals 0, j less than, what's the maximum length possible for this, for some particular I that should be equal to I minus 1. So you will just iterate up to that, and then you will check. Okay, one thing is important. You cannot iterate up to I, because we are only considering the proper prefixes. We are not considering the whole prefix. Okay, so you need to iterate only till I, sorry, less than I, and then um, we'll simply check whether this is a prefix or not. So if s dot substring, okay, so in case you don't know, this is an inbuilt function for finding the substring. So we are considering the j length prefix of this substring. So s dot substring 0 to j, um, if that is equal to s dot substring. Now, suppose I equal to 4 and j equals to 2. So for that case, you need to the starting index of the string to be such that should be equal to 4. Okay, so it's basically you write it. Sorry. Okay, I think I have given the numbering in a wrong way. It's basically, I think, just a minute. Okay, it was right. Okay, no problem. So yeah, for I equal to 4 and j equal to 2, your starting index should be 3. And if you like do some
So your voice is not coming.
Hello. Uh, is my voice coming?
Yes, sir.
I think I got disconnected. Sorry about that. So where was I? Can anyone tell me? Let me just share my screen again. So can anyone tell me where was I? Um,
So you were explaining the substring part.
this one, right? Yeah.
Yeah.
Yes.
So basically, what I was trying to say is that if you have to consider um, a substring of a prefix of length j, okay, and the total length of the string is I. Uh, Not the total length, but it's something like the last index is I. So this index, what you need to find here, the starting index, that should be I minus j plus 1. Okay. So if you do some math, you will find that this is the starting index, and length will of course be j, because they are equal when they have the same length. That is the only case possible. And if this holds true, then you can say that this is a like a possible value of pi. And what we are doing is that we are iterating in like increasing length. Okay. So we want, if we want to take the maximum length, we can simply like write pi of I equal to j. Okay. If we get a greater length in the future, that will replace this value. Okay. And so can anyone tell me what's the time complexity of this code?
Thank
O
you.
of n cube.
N
N
cube.
cube, right?
Yes.
Because this is two nested loops, one within each other, and in each of them you are having a string comparison, which is O of n. So O of n cube. Okay. So now this is not acceptable at all. We need to like improve this. Okay. Okay. So let's come to some optimization. First optimization is we are trying to optimize the second loop. Okay. Here you can see that this loop is running like this whole thing is running O of n square times. We want to like somehow optimize this O of n square up to O of n only. We don't want this to run so many times. So first we need to see an observation. The observation is that prefix of I plus 1 will always be less than equal to prefix of I plus 1. Okay. Now why this is holding true, let me just show you with an like a example kind of thing. So if you have a string like s0, s1, s2, and let me just make it more clear, s0, okay, whatever. So s0, s1, s2, s3. This basically si represents the character at the ith index. And say, let's say you had some string where like the first five characters were matching the um, last five characters. So let's say it was S8, S9, S10, S11, and S12. Okay, so by definition, here in this case, you have I of 12 equals 5, because I'm assuming that these first five characters were matching with these last five characters for substring 0 to 12. Now, suppose I want to find uh, what's the value of pi of 13. Okay, so consider uh, again this same string. Uh, Now let's add two more characters, S5 here, and let's say S13. Now we know that these first four characters are matching these five characters, first five characters are matching these five characters. Now we have two cases. First case is that if S5 is equal to S13. If that is the case, then we will have prefix function of 13, which is equal to prefix function of 12 plus 1. Okay, and if S of 5 not equal to S of 13, then we will have prefix function of 13 that will be somewhat less than prefix function of 12. Now, why this is holding true? The reason is that the prefix function at 13, uh, it cannot be more than prefix function of 12 plus 1. Because if that was the case, then let's say it was 7 characters. Okay, so if 7 characters of this new string were matching the first 7 characters of this string, then definitely um, there was like the value of S of 12 should have been 6. Are you like trying to get why is it so?
Yes, sir. Sir, can you also zoom in a little on the screen?
Yeah, sorry. So, is this much okay?
Yes, sir.
Okay. So this is one optimization that we can see. Now, one thing that we can notice here that if this pi of I plus 1 that can increase only by 1 at max. So out of the total string that we have, like this whole string, um, for all values of I, this can increase up to n times. Okay, so prefix of I can increase at most n times. Okay, and secondly, prefix of I cannot be negative. Okay, so if this can increase at most n times, and you will also notice that prefix of 0 is always 0. So what you can also see that prefix of I can decrease at most n times, because obviously if it is decreasing more than n times, then some of the prefix will become negative. Okay, so it can increase at most n times, it can decrease at most n times. So what you can say that this whole thing, uh, these two loops, if you like check this condition before iterating, like this condition s of 5 equal s of 13, meaning that if you check, like let me just show you. So this is the iterating. We are not changing anything to the loop. But if we check if s of prefix at I minus 1. Okay, so the prefix that was there in before, like this whole part, this will represent the prefix of I minus 1. So if s at that index, like here in this case, prefix of I minus 1 was 5. So if s of 5 is equal to s of I, then we can write I of, um, let's say, I equal to pi of I minus 1 plus 1. Okay, so I think I'm checking this in the wrong iteration, sorry. So here we are checking this condition before like iterating. So if this case is there, then it will straight away not even get into this loop. And if this is not true, then we are going to loop over the value of j, and we know that it can decrease at most n times. So we will try to check with the largest values of j only. So in this case, we are not trying to like go for 0 to I, we are trying to go for I minus 1 to 0, and we are decreasing. I think I wrote I here, sorry about that. And we are simply checking this condition, and if this is holding true, then we are making pi of I is j, and at the same time we are breaking it because we have already got the maximum length prefix, which is also a suffix. And I claim that these whole loops I and j, uh, the total time number of times these will be executed will be at most 2n, because the value of j will increase at most n times and the value of j can decrease at most n times. Okay, so uh, one more thing is that since we know that this thing cannot be more than pi of I, instead of starting from I, we can start with pi of I minus 1. Okay, because for pi of I minus 1 plus 1, we have already checked it here. So we'll start with something lower than that. And now I claim that this is total O of n square because these two loops combined, they are executing in O of n times, and this is also an O of n operation inside that, so this is O of n square. So just tell me, is this thing clear? How is this optimization helping us? So basically, if you are not getting it how this is O of n, you can see the example of like a monotonic stack where uh, you can see that you push elements at most once there, and each element is popped at most once. So even if it looks like the complexity of O is O of n square, the at most n times the elements will be pushed and at most n times the element will be popped, and so the complexity becomes O of n in that case. Similarly here also, uh, the value of j is increasing at most n times and decreasing at most n times. So total, out of all values of I, the value of j is iterating at most like 2n times. Okay, so just tell me if this is clear or not. Like if this is clear, you can write 1 in the chat or 0.
So can you explain the time complexity again? How it
The time
is
complexity,
ordered? Yeah. So how are the two loops running together into n time?
n times. Okay, so let me come back to an example. So suppose the prefix functions are something like this. Okay, so starting with 0, then you have 1, then you again have 2. Like first of all, the prefix function is increasing, and then let's say you drop down to 1, then again you can have 2, then you have 3, then 4, then you drop down straight to 2, and then you can have let's say 1. Okay, now what I claim is that at each of the iteration, the difference between this and this, the new one and the initial one, so this can be at most pi of I minus 1 plus 1. Okay, so what you can see is that um, it can increase at most n times because obviously there are n indexes, and at most once it can increase, so at most n times it can increase. And second thing is that the prefix function of a string can never be negative. Okay, it's always a positive number or 0. So if you are getting non-negative, and it can increase at most n times, and it starts from 0. Okay, it always starts from 0. So with all these three conditions, you can say that it can also decrease at most 10 times. Okay, because see, if you see this example, then from 2 to 1 it has decreased once, and from 4 to 2 it has decreased twice, and from 2 to 1 again it has decreased once. So here in this case it has decreased at most 4 times. So similarly, if you take like any example, you will see that the number of decrease will always be less than the number of increase. And so what I say is that since this j is just iterating either up or back, it's like a kind of a pointer kind of thing, because this j starts with prefix of I minus 1, and this will go up to 0, and as soon as we are getting a value to which it is satisfied, this is just breaking up. So this j is nothing but the differences between these. Okay, so in this case j will be like moving once, in this case it will be twice, in this case again sorry, this case also once, this also once. Okay, so all these cases j will be just increasing or decreasing once, and in this case it will be decreasing twice. And so if you like sum it all overall I, this will be at most 2n. Okay, because it has increased at most 10 times, it has decreased at most 10 times. So at total, it has decreased at most, it decreased or increased at most 2n times. So uh, is this thing clear now?
Yes, sir.
Okay. And basically here also you have an O of n, extra O of n for comparing these two strings. So overall it becomes O of n square. And this is also not the best we can achieve. This is also still a little more. So we need to optimize this also now. So now we are trying to optimize this second part. Okay. So we need to somehow find a way to compare strings faster than what we have been already doing. Okay. So coming to optimization 2. Okay. Um, let's say for some index I, you have pi of I equals j. It means that let me just make the string. So S0, S1, S2 up to S at um, j minus 1. Okay, j is a length, so the last index will definitely be j minus 1. Uh, just a minute. Yeah. So this is a prefix that matches with the suffix of length j. And as already said, the first index will be I minus j plus 1, and this will go up to s of I. So we know that this part is coinciding with this whole part. Okay, and we know that if s of j, um, this part matches with s of I plus 1, then let me just write it. If s of j equals s of I plus 1, we can say that pi of I plus 1 equals j plus 1. Okay, this has already been discussed in the first optimization. Now let's see if this is not the case. So if this is not the case, then we need to find some smaller string, some smaller prefix, which is also a suffix of this whole part. Okay, so prefix of I is just the largest suffix, but there can be some other suffix which is like smaller, but still it is a part of this thing. Okay, so let me just give you an example. If you have AAB A A, um, yeah. So suppose you have something like this. This is I equal to 4 here, and uh, prefix of this part is equal to 2, because A is common. It is a prefix, it is a suffix. Now, if you want to find a smaller prefix which is also a suffix of this, like if this A is a prefix which is also a suffix, then this single A which is there, this also satisfies this property. Okay. Now, if suppose the next character that you have to add here is B. Okay. No, sorry, it's not D, it's A. Okay. Suppose the next character that you need to add here is A. So you can see that S of J is not equal to S of I. But you can see that this smaller string which is there, suppose if you had taken this only A with this, then this A matches with this A. And now you can obviously see that this also has pi of I plus 1 equal to 2. Okay, so our task is that we need to find a value k such that the prefix of length k is also a suffix of length k. And we need to find this value of k which is less than j. And we need to find the maximum such value. Okay, the first such value which is satisfying this property. And if we can find this value which satisfies this property, then we will have I of I plus 1 is equal to k plus 1. So if we can find such a value, then we will be able to say that pi of I plus 1 will be equal to k plus 1. Okay, so coming to the part how we will find such a value k. Now notice that if you are trying to find such a value k which is satisfying this property, um, just a minute, let me just show you with an example. Let me just show you with an example.
सर पी आई प्लस वन के इक्वल होगा फिर के प्लस वन के.
Sorry,
सर पी आई प्लस वन इक्वल टू के प्लस वन लिखा है तो फिर के नहीं होगा यहाँ पर.
k plus 1 होगा ना, बिकॉज k का जो था ये k लेंथ का जो है वो सेटिस्फाई कर रहा था फॉर प्रीफिक्स ऑफ i के लिए. ठीक है, i तक के लिए सेटिस्फाई कर रहा था. और अगर हम ऐसा ढूंढ पाते हैं k सच दैट i प्लस सॉरी i के लिए वो सेटिस्फाई कर रहा था वो लेंथ का k, एंड ऑल्सो s ऑफ k इक्वल्स s ऑफ i प्लस 1. अगर ये भी सेटिस्फाई करता है, ये वाला कंडीशन भी, तब हम कह सकते हैं कि प्रीफिक्स ऑफ i प्लस 1 विल बी k प्लस 1.
Yes sir.
You can just try to think it that way. Now let me just show you how you can find such a value of k. So you had something like I minus j plus 1, then s of I minus j plus 2, and this goes up to s of I. Now suppose you have some value k. Okay, suppose this value of k here was equal to let's say 3. Okay, so s0, s1, s2. Now this is also satisfying the property at s of I minus 2, s of I minus 1, and then s of I. Now suppose k equal to 3. Now you can see that this part, this prefix, this is equal to this suffix. So if suppose some value of k is satisfying this prefix function property for some value of this suffix here, then that will this part like the suffix for which it is satisfying, s of I minus 1, s of I minus 2, and s of I, this part is also equivalent to the suffix of this part. So s of I minus 2, s of I minus 1, and s of I. This should be equivalent to s of j minus 2, s of j minus 1, s of j. You agree with this thing? Because uh, that is what the prefix function property was satisfying, right? अगर ये पूरा सबस्ट्रिंग इस चीज के इक्विवेलेंट है, सो इनके करस्पॉन्डिंग कैरेक्टर्स भी इक्वल होंगे. सो s of j minus 1 that should be equal to s of I, s of j minus 2 that should be equal to s of I minus 1, and s of j minus 3 that should be equal to s of I minus 2, right?
Yes,
Are
sir.
you getting this part? So basically now we have only to find the length of the longest prefix, which is also a suffix of this part, the s of 0 to s of j minus 1 part. Okay, so k will be the length of any proper prefix which is also a suffix of s of 0 to s of j minus 1. Okay, so if you understand this thing, then by definition this is nothing but pi of j minus 1. So are you getting this?
सर ये एस जे माइनस थ्री एस जे माइनस टू एस जे माइनस वन कैसे लिखा था?
uh, Consider these two strings. Okay, by definition ये दोनों equal थे, right? s of um,
यस सर, ये
let me
इक्वल
just
थे.
write it, s0, s1, s2, and up to s of j minus 3, s of j minus 2, s of j minus 1. This was equal to s of I minus j plus 1, s of I minus j plus 2, s of I minus j plus 3, and up to s of I minus 2, s of I minus 1, s of I. Now, if you notice, like the equality of string, if this is equal to this string, then corresponding character भी equal होंगे इनके. So s of 0 this is equal to s of I minus j plus 1. S of 1 जो था that was equal to s of I minus j plus 2. S of 2 जो था that was equal to s of I minus j plus 3. And similarly s of j minus 3 जो था that was equal to s of I minus 2, right? S of j minus 2 जो था that was equal to s of I minus 1, and s of j minus 1 जो था that was equal to s of I. So अगर तुम्हें कोई ऐसा प्रीफिक्स निकालना है जो इस पूरे चीज का सफिक्स है, तो फिर वो इस पार्ट का भी सफिक्स होगा, बिकॉज दिस पार्ट इज इक्विवेलेंट टू दिस पार्ट, राइट? जो पूरे स्ट्रिंग का राइट मोस्ट पार्ट था वो जे जे माइनस वन स्ट्रिंग के राइट मोस्ट पार्ट के भी इक्वल होगा, अकॉर्डिंग टू द डेफिनेशन ऑफ प्रीफिक्स फंक्शन.
यस सर.
इसलिए वी कैन राइट दैट your task reduces to finding the length of the longest proper prefix, which is also a suffix of this part, s of 0 to s of j minus 1. और प्रीफिक्स फंक्शन के डेफिनेशन के हिसाब से दिस इज नथिंग बट पाई ऑफ j minus 1. And so according to this we have k equal to pi of j minus 1. So now is this thing clear? What's the how we are trying to find the value of k? Just tell me if this is clear or not. Like you write 0 or 1 in the chat, and then you will see what is the final algorithm. Okay, so now coming back to the final algorithm, so you will start with 0. Okay, so we are just iterating over the values of I, and we will start by making pi of I equals pi of I minus 1. Okay, so we need to just handle one base case. So let's start I with 1 and like write pi of 0 equal to 0, because obviously if you have a single character and then there is no proper prefix of that uh, single character string, and so you don't have any proper prefix, and that's why we define pi of 0 as 0. And while iterating, you will start by making um, pi of I equals pi of I minus 1 plus 1. That is the maximum value that it can have. And you will start by making j equal to pi of I minus 1. Now, according to the condition, um, what we need to do here is we need to first find the value of k, and we need to check if uh, this thing is going to satisfy our like this condition. Um, the only condition that we need to check here is this: s of k equal to s of I plus 1. And if this is satisfied, then we can say that this k value is actually the value of pi of I. So we need to check until this value of j becomes equal to 0. So our condition here is something like this: while j is greater than 0, because obviously you can't take a 0 length kind of prefix and you can check with that, so that is not possible. So while j is greater than 0 and s of I not equal to s of j, not s of yeah, sorry, s of I is not equal to s of j. So the last character that we are trying to check, if that is not equal to the character just after this j minus 1, that is the case, then we need to find the value of k, and we will get int k equals pi of j minus 1. Okay, and this is and then we'll make j equal to k minus 1. Okay, sorry, we'll just make j equal to k, because now what we need to do is that once if we don't get this k satisfying this property, if the value of k that we get this does not satisfy this property s of k equals s of I plus 1, then we can like just reduce this whole k to the substring um, sorry, this whole I to the substring j minus 1. Okay, like basically what we are trying to do is that इस पूरे सबस्ट्रिंग जो था I तक का, that we managed to reduce it to j minus 1. So if this is also not satisfied, then this j minus 1 should be reduced to k minus 1, right? So basically that's what we are doing. We are making j equals to k, and we will continue while we get until we get some condition like this: s of I not equal to s of j. And once we get the condition, we need to check if s of um, j equals s of I, and this holds true, then we can say pi of I equals j plus 1. And else, if this is also not holding true, then we can simply say pi of I is 0, because we have not got any such string which is satisfying this condition, so we can write pi of I equals 0. Otherwise, we can say that this is our uh, longest common prefix, which is also a suffix. So, first of all, tell me, is this code clear?
So can you please repeat this with an example, this code?
Okay. So let's say you had A B C A B, then you had D A B C A B. Okay. Suppose this was pi of I minus 1. Okay. Now in this case you are having pi of I minus 1, that is what's the value of pi for this string? I think this is 5, right? Because abc this is a common prefix which is also a suffix, and you cannot include this d. Okay, so this value is 5. Now let's say the next character that you need to check, pi of I that you need to check. So the string becomes abc abd abc ab, and then c if you have. Okay, the next character is c. So first you have j equal to pi of I minus 1, which is 5. Now you will check if s of 5 equal to s of I, which is I think I equals here 12. No, 11, right? Here I equal to 11. Okay, I equals to 11 here. So we will check if s of j equals s of I. So j is nothing but 5 and s of I is the last character, which is c. So this is not holding true. Okay, so we need to find a smaller value which is also satisfying the prefix property for this string. So what I can say is that if these first 5 characters were equal to the last 5 characters, and if you have some string, let's say AB, which is satisfying the which is also a suffix of the whole string AB, then also this AB is a suffix of this string of 5 characters. Okay, so nothing but pi of 5 minus 1, pi of 4, pi of j minus 1. So pi of 4, that should be equal to the value of k. And for 4, A, B, C, A, B, you had 2, like A, B, which was satisfying this property. So you can say that 2 is a like a candidate. 2 is a possible value that can like satisfy this property for the last character. Now we will check. Now what we will do in the next iteration, we will make j equal to 1. So j becomes equal to 2, and then we will check if s of 2 is equal to s of I. So this C matches with this C. So we can also say that this whole string ABC will match with the suffix ABC, because this AB is obviously matching this suffix AB, right? So in this case, we can write pi of I equals to 3, which is equal to j plus 1. Okay. Now, if we suppose didn't had this C here, if instead of C we had some character like Z, which is not appearing in the string at all. So if the Z was there, this J will keep on reducing, और तब तक reduce होगा जब तक J greater than 0, मतलब J equal to 0 नहीं हो जाता. And as soon as J equal to 0, so at last we will check S of J equal to S of I. But this A will never be equal to the last character, which is Z. Okay. So in that case, you can say that there does not exist any such prefix which is also a suffix. So pi of I equal to 0. That is the second case in the else part. So now are you getting it? The algorithm?
Sir, everything is fine, but when we reduce it by pi of j minus 1, so is it necessary that because the strings were different when pi of j minus 1 was calculated, so is it necessary that we have to bring j to k?
Sorry, it is necessary that we have to.
We have to update the value of j with k, like it cannot
Yeah,
be j
that
minus
is
1.
necessary, right? Because any such prefix which is like any such suffix which was there for the whole string, that is also equivalent to a suffix for the string that was up to j. Okay, this way you are getting the relation, like this whole prefix which was there, if this is present as a suffix in this current string, then this was also present as a suffix in the string when j was equal to this 5. मतलब कि जब हम कंसिडर कर रहे थे ये पाई ऑफ 4 जब हम निकाल रहे थे, तब ये जो भी स्ट्रिंग हमें मिल रही थी, लाइक दिस ए बी वी वर गेटिंग. So if this AB is supposed to be a substring of this whole string. तो ये AB जो था ये उस केस में भी एक तो प्रीफिक्स था जो सफिक्स भी था उस स्ट्रिंग का. This is actually necessary because this string is equivalent to this string according to the definition. ये दोनों equal है. Equal तभी होंगे जब मतलब अगर equal है so obviously this part will be equivalent to this part also.
सर बट जब हम पाई ऑफ आई कैलकुलेट कर रहे थे तो हमने फुल जो n लेंथ की स्ट्रिंग थी उसके सिर्फ आई कैरेक्टर्स एक्सट्रैक्ट करके उस पर चेक किया था ना.
हाँ.
तो अब मैंने सपोज i+1th कैरेक्टर डाला
हाँ.
तो हाउ इज इट नेसेसरी कि जो ith के अंदर प्रीफिक्स था वो i+1 वाले के अंदर भी सफिक्स होगा.
That will for that only we are trying to check this condition ना. Suppose I का जो prefix था वो I का जो prefix और suffix था. Okay, suppose that was some prefix and suffix in I. अगर इसको i+1th में कन्वर्ट करना चाहते हैं तो क्या डिफरेंस होना चाहिए. जो लास्ट कैरेक्टर हम ऐड कर रहे हैं वो जो है इसके लास्ट कैरेक्टर के बराबर होना चाहिए, राइट. लेट्स से यहाँ पे ये 5 कैरेक्टर्स तो हमारे सेम थे ही इनमें से. बस डिफरेंस क्या होना चाहिए, जो लास्ट कैरेक्टर है सी ये इसके लास्ट कैरेक्टर के बाद वाला जो कैरेक्टर है उसके इक्वल होना चाहिए, तभी ना तो वो सेम हो जाएगा सफिक्स. यही बस एक कंडीशन नेसेसरी है बिकॉज ये पार्ट तो सेम था ही ऑलरेडी दोनों में. बस अगर नेक्स्ट कैरेक्टर भी सेम हो जाए तो सेटिस्फाई हो जाएगा ये सफिक्स. और अगर ये कैरेक्टर सेम नहीं हुआ तो ये पूरा प्रीफिक्स भी सेटिस्फाई नहीं होगा. इसके लिए हमें एक ऐसा कैरेक्टर ढूंढना होगा सच दैट ये पार्ट तो सेटिस्फाई हो ही रहा है हर केस में, लेकिन साथ में ये वाला पार्ट भी सेटिस्फाई हो. लास्ट कैरेक्टर जो है इस प्रीफिक्स के बाद वाला कैरेक्टर के इक्वल हो. ओके, क्लियर है जिसने भी पूछा था.
Yes, sir.
ओके, टॉकिंग अबाउट द टाइम कम्प्लेक्सिटी. तो लाइक प्रीवियस एग्जांपल मैंने बोला था ये जो j की वैल्यू है ये एट मोस्ट n टाइम्स इंक्रीज और डिक्रीज होगी. सो दैट इज ऑब्वियसली o ऑफ n फ्रॉम द प्रीवियस ऑप्टिमाइजेशन. इधर पे क्या ऑप्टिमाइजेशन हो रहा है, इधर पे हम स्ट्रिंग्स कभी भी कंपेयर नहीं कर रहे, इधर पे सिर्फ कैरेक्टर्स कंपेयर हो रहे हैं. s of i, s of j, here also s of j, s of i, and this is also like all constant time operations. So in this case this is an o of n code. Okay, the complexity of this thing is o of n. And like this part is not necessary, you can just remove this line because prefix of I anyway यहाँ पे assign हो ही रहा है, so that line was extra. Okay, so are you getting how is the time complexity o of n for this thing? Like if you have some doubts I will just give you an link to an article. So on CP algorithms, like there's a very good article on Kmp algorithm. So this is a link that I'm including in the doc. You can like go through this link for a proper like description and proof if you want to read. Okay, so this part is clear, right? This prefix function. Anyone having doubt in prefix function? Anyone, any doubts? Okay, fine. If it's clear, then let me show you the applications. Okay, so this is all that we have done so far, but iska application kya hai? So let's see what's the application of this things. Okay, suppose you are given two strings s and t. Okay, those strings दिए s and t, and you need to find the number of occurrences of t in s. ओके, सपोज दो स्ट्रिंग दिए एस और टी और तुम्हें फाइंड करनी है कि टी कितनी बार एस ऑफ आ रहा है, एस में आ रहा है एज अ सबस्ट्रिंग. सो लेट्स से इफ आई गिव समथिंग लाइक A B C, or let me just give you A B A B A B A. Okay, अगर ये मेरा string है and T equal to A B A, so what you can see is that यहाँ पे एक A B A आ रहा है as a substring, then you are getting A B A here and you are getting A B A here. So there are 3 times it is appearing as a substring. So ऐसे तुम्हें count करके बताने कितनी बार आ रही है. And the constraints that you have is length of S and length of T all are less than equal to 10 power 5. Okay, so can anyone just first come up with some basic approach like O of n cube, O of n square, something like that? Like O of n cube is very simple. So anyone can come up with O of n cube approach? Okay, leave O of n cube. Sorry, can anyone come with O of n square approach?
Yes, sir. For we start from first index and we compare up to
Compare
t,
the
up
whole
to t length.
substring
We
of
compare
length.
it equivalent.
Yeah, you basically start with each index. You will iterate over the starting index, and you will compare the substring of this length, and you will compare it with t if this is equal or not. Okay, so this is basically a O of n square approach, but the constraints here is 10 power 5, so O of n square will not work. So can anyone like think of some way of optimizing this using some kind of what we have read above, the Kmp algorithm? So can anyone just think of it? Okay, let me give you an hint. Um, Try to find the prefix function of s plus, this is a character, hash hash plus t. Okay, this is just a single character hash you are inserting between the s and t. So the string will become something like aba aba ba hash aba. So try to find the prefix function of this thing and try to relate it with our problem. If you can see any similarity between these two. Okay, can anyone just tell me what will be the prefix function of this thing? Like the first few um, elements of the prefix function array. Anyone?
A, sir.
क्या?
So first index it will be A.
Zero.
Yes, sir. 0.
Like इस सबस्ट्रिंग को अगर खाली कंसिडर करोगे तो जीरो है. इस केस में ए बी में अगेन जीरो, राइट?
Yes, sir.
Then one.
ए बी ए
Then
में
1.
वन,
Again one.
वन, राइट? देन for this
2, sir.
2.
2.
two, correct? Okay, actually I'm not interested in the whole thing. um, I'm interested. Just a minute. Sorry. I think I wrote it in wrong way. This should be the reverse. I just realized it. Sorry for that. Okay. Yeah. Now can anyone tell me?
Then 0,
Zero.
0.
Right. Zero. Okay.
So 1,
One. Then
then 0.
zero. Right. Okay. Now the main part comes from here. This is important. Like these things are not important. From here, this is important. So for this string,
So 1,
1.
one. For
2.
this, 2, then the next
3.
one
3.
3, then
1, sir.
1, right?
Yes.
Because single A, this A is matching with this A. Then for this whole part,
2, sir.
2.
right? Then for this part,
3. 3, sir.
3.
3. And then again, if you see, you will have 2 and then 3. Okay. So what I claim is that जहाँ भी तुम्हें 3 मिल रहा है, that represents a match where you have T as a substring of S. जहाँ भी तुम्हें 3 मिल रहा है, like this A भी है, इधर पे जो था, यहाँ पे जो था, and यहाँ पे जो है, so this 3 represents a match. So if you get pi of I is equal to length of T, then that represents that T is appearing as a substring in S. Uh, are you getting it? Why is it so? Like you just
Yes, sir.
try to see with the example, you will understand
Yes, sir.
why this
Yes,
this
sir.
condition is holding true. Okay. So this is one application of KMP. You can like simply count how many times this is appearing. And one more thing is that if you like see for all of these, like जो 2 हो रहा है 3 हो रहा है, what this 2 and 3 represents? This represents nothing but इनके सारे prefix के भी तुम निकाल सकते हो, not just for the string T. You can find for each prefix of the string T also, like AB कितने बार आ रहा है, A कितनी बार आ रहा है, so that you can like find out. Okay, so that I will come to the next problem. So इसी problem पे आते हैं. Suppose you are given two strings S and T. You need to find the number of occurrences of each of the prefix of T in S. ठीक है, अभी तुम्हें सारे prefix के लिए solve करना है, not just the whole string T. Okay, so this is a little tricky. This is like not exactly like it seems to be, but it's a little tricky. Let me tell you. So try to construct something similar to it, and just this thing is going to change.
सर ऊपर वाले का जैसे ही करेंगे बट इसमें
Less than equal to.
हाँ इसमें टी
Less
का
than
टी वाला पार्ट का भी अलग से करेंगे और एस का जो रिजल्ट है उसमें से टी का सब्ट्रैक्ट कर देंगे पार्ट
S का रिजल्ट आया T से सब्ट्रैक्ट कर देंगे मीन
मतलब टी का अलग से निकालेंगे वो प्रीफिक्स फंक्शन और एस टी प्लस एस का भी निकालेंगे
T का
T
अलग से
plus-
निकाले प्रीफिक्स फंक्शन. लेट्स से इसी एग्जांपल को लेते हैं. सो
हाँ.
ये तुम्हारा S T प्लस हैश प्लस S का प्रीफिक्स फंक्शन था
हाँ
और T का
और
प्रीफिक्स
इसमें-
फंक्शन क्या होगा? 0 0 1.
हाँ ये पार्ट रिमूव कर देंगे इसमें से
मीनिंग इसको हटा दिया और ये
हाँ.
हैश को भी हटा सकते हो, कोई जरूरत नहीं हैश का.
हाँ हाँ अब इसमें वन का ऑकरेंस बता देगा कि अप टू लेंथ वन का कितना प्रीफिक्स है
बट
टू का
एक
बता
मिनट,
देगा
1 का कितना बताएगा इसमें? 2 बताएगा सिर्फ.
सर 2 के केस में भी ऐड करेंगे 1 के लिए सर.
2 के
अच्छा,
केस
हाँ,
में
हाँ,
भी
हाँ.
ऐड करेंगे.
यस सर.
हाँ, हाँ, हाँ.
यस सर 2 या 3 जब दोनों होगा.
एक मिनट. A कितनी बार आ रहा है? फर्स्ट ऑफ ऑल जस्ट टेल मी, A कितनी बार आ रहा है S में?
हाँ
5 बार आ रहा है, राइट? सो खाली 1 लेने से तो चलेगा नहीं.
Yes.
हाँ 3
One,
का
two,
फ्रीक्वेंसी
three.
प्लस सबका फ्रीक्वेंसी
इट्स नॉट लाइक दैट. इट्स 1 और 3 दोनों का ऐड करना होगा. नाउ व्हाई इज इट सो? लेट मी जस्ट शो यू. A B ये जो स्ट्रिंग था हमारा, दिस स्ट्रिंग, इसमें इसका जो प्रीफिक्स फंक्शन होगा, लाइक A B A का जो प्रीफिक्स फंक्शन है, क्या था इसका प्रीफिक्स फंक्शन? 0 0 1 था, राइट? सो जो ये 1 है, इट रिप्रेजेंट्स दैट इसका जो सफिक्स है वो इसके प्रीफिक्स के बराबर है, खुद के प्रीफिक्स के बराबर है. सो हम ये कह सकते हैं कि ये जो अगर इसका जो अकरेंस आ रहा है A B A का, उसमें जो है ए का भी ऑकरेंस आएगा. दैट यू आर गेटिंग इट राइट. अगर
Yes, sir.
ए बी ए किसी का होगा सफिक्स, सो यू कैन ऑल्सो से दैट ए बी उसका सफिक्स है.
Yes,
एंड
sir.
प्रीफिक्स फंक्शन लार्जेस्ट देता है, तो कोई तरीका नहीं हमें 1 का ट्रैक करने से, बट हम 1 जो है वो 3 से मतलब डिराइव कर सकते हैं. बेसिकली व्हाट आई एम ट्राइंग टू से इज दैट
सर वो सारी सब स्ट्रिंग लेनी होंगी जिनमें ए आ रहा है.
सारी सब स्ट्रिंग लेनी होगी जिनमें
ए आ रहा है, मतलब ए
नहीं,
का अगर
सारी नहीं
occurrence
लेनी
count
होगी.
करना.
मैं बता रहा हूँ सारी क्यों नहीं लेनी होगी. ये प्रीफिक्स फंक्शन से इजीली हो जाएगा अगर तुमने टी का भी प्रीफिक्स फंक्शन निकाल रखा है तो. सो let me just first write the code and then explain to you. Okay, so basically we are first making a string, let's say x, which is equal to t plus hash plus s, and let's say we have a vector int pi equals to let's say we have made a function to implement prefix function. I'm not going to write the function again. So prefix function of x. Okay, so that ये जो vector pi है, this will represent something like ये वाला, जो कि पूरा ये वाला हमारे लास्ट एग्जांपल में जो वेक्टर हमें मिला था. Okay, now some parts here are like not at all required. So of course these parts are not required हमें, so हम इसको ignore मारेंगे. We are not going to like take care of these thing at all. And now what we are trying to do is that we'll make a vector int answer, and this will be m plus 1, where m is the length of the like the string t, जो भी हमारा सर्च स्ट्रिंग है t, उसका लेंथ m है सपोज. तो हम एक आंसर बना देंगे जिसमें हम स्टोर करेंगे कि उतना प्रीफिक्स का लेंथ का जो है कितने ऑकरेंसेस आ रहे हैं. So first and foremost we can iterate I equals to अब this is important, how from where to start. इसका लेंथ m है और एक एक्स्ट्रा कैरेक्टर है. So at m plus 1 कैरेक्टर्स जो है that are useless to us. So m plus 1 को अगर हम छोड़ दें, so thus index of this thing, this will be m plus 1, है ना. So this should be a starting index, and कहाँ तक iterate करना है, the whole length of this array should be n plus m plus 1. तो ये है हमारा I mean this part, जो हमारे काम का पार्ट है, यूजफुल पार्ट. और इसमें जो है हम चेक करेंगे we'll just assign answer of I, not I, answer of pi of I plus plus. So basically हमें बता देगा कि ये इसका इनका ऑकरेंसेस कितना है. बेसिकली फ्रीक्वेंसी हम काउंट कर रहे हैं. So right now you have answer of 3 is 3, answer of 2 is also 3, and answer of 1 is 2. Okay, now in the next loop we will like iterate over the lengths. So I equal to m plus 1, I greater than 0, I minus minus. Now इसमें हम क्या करेंगे, we will make answer of I of I minus 1 plus equal to answer of I. Now why are we doing this? Notice one thing. When I is equal to when I is equal to m, that means the length of 3. So जब I 3 था, so we know that जो 3 का prefix function होगा, that will represent the longest prefix, which is also a suffix of this prefix of t, which is of length 3. So ABA अगर देखो तो इसमें pi of this ABA is 1. So this represents that this A matches with the end of this A. So what will this represent? अगर ABA जो है ये कहीं पे occurrence आ रहा है, सो दिस विल ऑल्सो मीन कि ये ए जो है दैट विल ऑल्सो बी एन ऑकरेंस, मतलब कि जो ए वाला पार्ट है दिस प्रीफिक्स ए वो भी अपीयर करेगा, बिकॉज बेसिकली लेट मी शो यू विद अ बिगर एग्जांपल. ओके, सपोज तुम्हारा सर्च स्ट्रिंग जो है इट वाज समथिंग लाइक ए बी सी ए बी, ऐसे अगर तुम्हारा सर्च स्ट्रिंग था तो जहां भी ए बी सी ए बी आ रहा है, लाइक जहां भी ए बी सी ए बी सबस्ट्रिंग आ रहा है एस में, सो ए बी भी उसमें सबस्ट्रिंग के तरह से आएगा. मतलब अगर एंड मैच कर रहा है किसी सबस्ट्रिंग का ए बी सी ए बी के साथ, तो उसका एंड जो है वो ए बी के साथ भी मैच करेगा, because ab is a prefix which is equal to the suffix of this thing. So that's why answer of pi of I minus 1, like इसका pi जो है 2 था, so answer of like pi of this thing, इसका index जो है 5 minus 1 which will be equal to I think 4, so pi of 4 जो है that was equal to 2, उसमें हमें add करना होगा answer of I. Okay, so coming back to our previous example, pi of 3 was 3. So in that case, we need to add answer of 1 plus equal to answer of 3. Because जो 3 का जो सबस्ट्रिंग था, मतलब 3 पे अगर कोई ऑकरेंस आ रहा है, so उस केस में 1 का ऑकरेंस भी आने वाला है. In that case, it has to come. Okay, that's why we are adding answer of 3 to answer of 1. And here you will get answer of 1 equal to 5 after this operation. And others will not change. Answer of 3 will remain answer of 3. Answer of 2 will remain 3. So just tell me if this is a little confusing, I think. So just tell me if you don't understand this. Or if you understand, then write 1.
We are adding in one because in prefix function of 3 1 is coming.
बिकॉज देखो तुम जब 3 का ले रहे थे कोई भी ऑकरेंस, तो वो एक चीज से एंड हो रहा था पर्टिकुलर चीज से, ठीक है,
Yes, sir.
वो एंड मैच कर रहा था कहीं से,
sir.
बट वो एंड जो है स्टार्टिंग से भी मैच कर रहा है. सपोज पाई ऑफ जो था पाई ऑफ आई, ये वाला पार्ट,
Yes,
इस
sir.
पे भी वो एंड मैच कर रहा था, वो स्टार्टिंग से भी मैच कर रहा है और वो उस पूरा सबस्ट्रिंग से भी मैच कर रहा है. तो स्टार्टिंग वाला तो तुम काउंट कर नहीं रहे हो, बिकॉज पाई व्हाट इट रिप्रेजेंट्स द लॉन्गेस्ट प्रीफिक्स थिंग. ठीक है, जहां भी तुम्हारा ए बी ए तीनों आ रहा है वहां पे ए तो काउंट करेगा नहीं, बिकॉज लॉन्गेस्ट काउंट करेगा वो.
Yes, sir.
इसलिए तुम्हें ये ए का जो मिस हो रहा है इसको कंपेंसेट करने के लिए ये ए बी ए का जो था नंबर ऑफ ऑकरेंसेस वो भी ऐड करना होगा. ओके
सर ऐसा बोल सकते हैं कि टी के प्रीफिक्स में जिनकी लेंथ आई से बड़ी है उनको ऐड कर रहे हैं.
आई से बड़ी हो,
हाँ, मतलब जैसे आंसर ऑफ आई में जैसे आंसर ऑफ 1 में 3 ऐड कर रहे हैं, क्योंकि 3 पे टी के प्रीफिक्स में 1 था.
हाँ हाँ ठीक है. फिर
ये सर क्योंकि वो आ जाएगा ना, 1 आ जाएगा उसमें.
हाँ, बिकॉज जहाँ भी 3 एंड हो रहा है वहाँ पे 1 का भी प्रीफिक्स एंड हो रहा है.
Yes,
और
sir.
बात ये है कि जब तुमने 3 ऐड किया था तो तुमने 1 को इग्नोर कर दिया था, बिकॉज
Yes, बड़ा
तुमने
लिया था.
लॉन्गेस्ट लिया था. बट अगर तुम लॉन्गेस्ट नहीं लेते, अगर तुम मतलब सारे लेंथ के लेते, अगर प्रीफिक्स फंक्शन लाइक प्रीफिक्स फंक्शन बेसिकली डिफाइंड लॉन्गेस्ट के लिए होता है, लेंथ ऑफ लॉन्गेस्ट प्रीफिक्स, बट जरूरी नहीं है कि वही एक लौता प्रीफिक्स हो, दे कैन बी स्मॉलर प्रीफिक्स आल्सो. तो वो जो स्मॉलर वाले जो मिस हो रहे हैं उनको कंपेंसेट करने के लिए तुम्हें लॉन्गर वाले से ऐड करना होगा उनका ऑकरेंस. ओके
ये सर इसीलिए फॉर लूप को उल्टा ले गए हैं.
हाँ, फॉर लूप को इसलिए उल्टा ले रहे हैं बिकॉज हो सकता है वो जो नया ऐड हुआ सपोज
sir.
तुमने प्रीफिक्स ऑफ 5 में प्रीफिक्स ऑफ 3 को ऐड, सॉरी 3 में 5 को ऐड किया, बट ऐसा भी हो सकता है कि अभी 3 जो है 1 पे ऐड हो, सो इन दैट केस वो कंसिडर करने के लिए हम उल्टा जा रहे हैं,
Yes, sir.
सो दैट 5 का 3 पे ऐड हो और 3 से 1 पे ऐड हो, तो 1 पे 5 का भी अल्टीमेटली ऐड हो गया.
Yes, sir.
ओके, बेसिकली ऑल केस कवर हो जाएंगे अगर तुम रिवर्स वे में जाओगे.
Yes, sir.
Okay, so like there are many like applications of prefix sum. This is just one of the application. ऐसे कई application होते हैं. For example, you can also find the length of longest palindromic prefix of a string. Okay, so question is, you are given a string s, you need to find the length of longest palindromic prefix of s. Now palindromic समझते होगे कि जिसको रिवर्स और सेम वे में सेम रहता है, मतलब रिवर्स करने से भी सेम रहता है. सो तुम्हें क्वेश्चन यही है कि एक स्ट्रिंग दिया है और तुम्हें लेंथ ऑफ लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स बताना है इसका, एंड दिस थिंग विल बी यूजिंग इन अ प्रॉब्लम. मतलब एक प्रॉब्लम देखेंगे इसमें हम ये मतलब चीज यूज करने वाले हैं, लेंथ ऑफ लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स. सो दिस इज लाइक वेरी मच सिमिलर टू द फर्स्ट प्रॉब्लम दैट वी डिस्कस्ड. सो एनीवन, मतलब कुछ ऐसे ही करना होगा, कुछ किसी स्ट्रिंग में किसी चीज को ऐड करना होगा एक हैश के साथ. द ओनली थिंग इज दैट उसको क्या मतलब वो क्या होगा जो हम ऐड कर रहे हैं, किस वे में ऐड करना होगा हमें. एंड देन
So initial string के reverse को initial string के reverse में hash लगा के search string डालना.
yeah, so basically you you need to first you need to find the prefix function of s plus hash plus reverse of s. okay, अगर s को हैश देके रिवर्स ऑफ s में डाल दे, लेट्स से a b a c a b a, ये स्ट्रिंग था. एक और ऐड कर देते हैं c. ओके, सपोज ये हमारा स्ट्रिंग था और इसका लेंथ ऑफ लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स बताना है. सो अगर हम इसी को रिवर्स करके ऐड कर दे हैश के साथ, सो यू शुड गेट समथिंग लाइक हैश c a b a c a b a. or if you find if you like calculate prefix of let's say pi of the last index, मतलब इसका last index जो भी होगा that should be equal to 2 into n, exactly 2 into n, because इसका length जो है 2 into n plus 1 होगा. So if you calculate pi of 2 into n, then this will be the length, this will be actually the longest palindromic prefix of s. Now why it is happening like that? ये डेफिनेटली एक प्रीफिक्स होगा, बिकॉज अगर तुम इसके रिवर्स वे में जा रहे हो, सो इसका जो सफिक्स होगा दैट विल बी अ प्रीफिक्स ऑफ द ओरिजिनल स्ट्रिंग. इसका रिवर्स का जो सफिक्स है वो नथिंग बट एक प्रीफिक्स का रिवर्स्ड वे है ना. So this a nothing but this is it represents this a, this b is nothing but matching with this b, this a is matching with this a, and so on. So अगर इसमें से कोई पार्ट इस डायरेक्शन में मैच कर रहा है, लाइक ए बी ए, दिस इज मैचिंग विद ए बी ए. ओके, एंड दिस ए बी ए सी ए बी ए, ये पार्ट जो है पूरा, दिस इज मैचिंग विद दिस पार्ट. एंड द थिंग इज दैट हमने रिवर्स कर दिया है, बट हम कंपेयर जब कर रहे हैं तो हम एक ही डायरेक्शन में कंपेयर कर रहे हैं. सो दिस नथिंग बट ये मैच तभी करेंगे जब एक पैलिंड्रोमिक प्रीफिक्स होगा. समझ रहे हो? The prefix of this string will match with the suffix of this string only when जो prefix तुम consider कर रहे हो वो palindrome होगा, तभी मैच करेगा, because तुमने रिवर्स करके रखा है इस डायरेक्शन में. Okay, are you getting it?
Yes.
ये बोल दो या फिर चैट में लिख दो अगर क्लियर है तो. ओके, सो अगर तुम पूरे स्ट्रिंग पे ले रहे हो दैट इज पाई ऑफ 2 into n, तो बेसिकली ये जो लॉन्गेस्ट ऑब्वियसली तुम्हें दे रहा है. यस,
n+1/2 का फ्लोर पे भी तो मीन्स लेके और देख सकते हैं वैसा टाइप
नहीं
से.
वो नहीं देख सकते ना, इसकी बात कर
डबल
रहे हो ना.
यस सर.
तो इस पे नहीं देख सकते ना बिकॉज द थिंग इज दैट
नो सर मीन्स हाफ ले फिर हैश फिर हाफ का रिवर्स मीन्स n+1/2 फ्लोर ले और
यू मीन हाफ, इधर
Yes.
इतना बस लेना चाह रहे हो, ए बी ए सी एंड देन
यस
इसको
यस सर
हटा
रिवर्स.
देंगे.
यस
बट
मतलब
यू आर लूजिंग सम इंफॉर्मेशन ना उस केस में.
यस सर.
मतलब व्हाट्स द इंट्यूशन बिहाइंड रिमूविंग दिस हाफ पार्ट.
सर मीन्स अगर पैलिंड्रोम होगा तो जो फर्स्ट वाला है वो मतलब उस साइड वाले के मतलब रिवर्स का मीन्स इक्वल होगा. तो
नहीं,
फिर
जस्ट टेल मी व्हाट आर यू ट्राइंग टू फॉर्म द स्ट्रिंग. मतलब स्ट्रिंग क्या बनाना, लाइक आई चोज द स्ट्रिंग s plus hash plus reverse of v s.
यस सर.
तुम क्या
तो
बनाना चाह रहे हो?
सर s/2 मीन्स s 0 to
Okay, half of the string s. Okay, half s. फिर
yes sir plus hash plus reverse of half of this.
reverse of the same half की reverse of the other half.
Yes sir, reverse of other half. Yes.
नहीं, एक्चुअली वो गलत हो जाएगा. द थिंग इज दैट यहाँ तो तुम्हें पता था कि ऑलमोस्ट पूरा स्ट्रिंग जो है मैच कर रहा है, बट इन अ जनरल केस लेट मी से ये मैच अगर नहीं कर रहा होता, ए बी सी था, अगर ऐसे होता ये ए बी सी डी ऐसे कुछ होता, तो इस केस में सिर्फ एक ही प्रीफिक्स मैच कर रहा है विच इज ए बी ए. तो अगर ये जो पार्ट है ये तो तुम्हारा पूरा एक ही हाफ में हो जाएगा, ये दूसरे हाफ में पहुंचेगा ही नहीं, तो कभी मैच ही नहीं कर पाएगा ये पार्ट खुद के साथ. तो
अगर सारे कैरेक्टर को सेम ले लिया तो आंसर पूरा होता है, लेकिन उस केस में आप ही आए.
आई एम कमिंग टू दैट एक्चुअली. गुड थिंग यू नोटिस. आई एम कमिंग टू दैट, जस्ट अ मिनट. या सो पहले बता दो, ये केस के लिए सिंपल है. देयर इज अ स्पेशल केस दैट यू नीड टू चेक. आई विल कम टू दैट. सो व्हाट वर यू टेलिंग. जो भी अभी बोल रहा था सारे कैरेक्टर सेम होते तो
अगर सारे कैरेक्टर सेम होते और अगर हाफ करके चेक करते,
सारे कैरेक्टर सेम होते हाफ करके चेक करते तो
मतलब वो एट मैक्स हाफ ही बता सकता था प्रीफिक्स
हाँ.
की लेंथ को.
हाँ ऑफ कोर्स, बिकॉज ये हैश जो तुम दे रहे हो बीच में, इसको सेपरेटर बोलते हैं. ये हैश जो है कभी भी मतलब इंटरफेयर नहीं कर सकता कोई भी.
Yes, sir.
तुम्हारा जो प्रीफिक्स का लेंथ होगा ना पाई ऑफ आई, वो इतना तक ही लिमिटेड होगा.
Yes, sir.
ये हैश के साथ कभी इंटरफेयर कर ही नहीं पाएगा. सो दैट केस में भी गलत हो जाता तुम्हारा, है ना. ओके, सो ये पार्ट क्लियर है ना सबको. लेंथ ऑफ लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स. और लॉन्गेस्ट ऑब्वियसली लॉन्गेस्ट बताएगा बिकॉज प्रीफिक्स फंक्शन में भी तुम्हें लॉन्गेस्ट ही बताता है. सो दिस विल गिव यू द लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स आल्सो. Okay, this is clear. Then let's just do one problem from code forces. So I am posting a problem in the chat and also in the doc. So basically let me just explain to you what is the problem. तुम्हें एक string दिया है s और तुम्हें इसमें से एक string निकालना है such that t जो है that is formed by some prefix of s and some suffix of s. मतलब t जो है वो तुम थोड़ा स्टार्ट से कैरेक्टर ले रहे हो s का और थोड़ा एंड से ले रहे हो, और ऐसा होना चाहिए कि t पैलिंड्रोम है. ओके, लाइक अगर मैं एग्जांपल दिखाऊं, दिस ए बी सी डी, ये जो एग्जांपल है फर्स्ट वाला, सेकंड एग्जांपल. सो इन दिस केस You are taking this much A B C D F D, इतना पार्ट जो है तुम A में ले रहे हो, जो क्वेश्चन में A दिया है, और ये जो C D A पार्ट जो है ये तुम C B A पार्ट जो है ये तुम B में ले रहे हो. ओके, सो बेसिकली तुम्हें क्या करना है, ऐसा लॉन्गेस्ट सबस्ट्रिंग चूज करना है जो मतलब प्रीफिक्स और सफिक्स से बना हो, सच दैट वो एक पैलिंड्रोम भी हो. ओके, so that is the question. Is this clear to everyone, the question? Okay, I guess it's clear then. So anyone can come up with any approach. Okay, just try to think it that way. अगर पैलिंड्रोम बनाना है हमें टी को और कुछ सफिक्स और प्रीफिक्स ले रहे हैं, सो व्हाट शुड बी द नेसेसरी कंडीशन. अगर सपोज कोई भी सफिक्स तुम कोई भी प्रीफिक्स लोगे, सो उनका प्रीफिक्स में से जो फर्स्ट कैरेक्टर होगा वो ए से ही स्टार्ट होगा, सफिक्स का फर्स्ट कैरेक्टर होगा वो ए से होगा एंड, मतलब सफिक्स का लास्ट कैरेक्टर ए से एंड होगा. सो द कंडीशन जो है, तुम मतलब कुछ स्ट्रिंग कभी ले सकते हो जब ये लास्ट कैरेक्टर और ये फर्स्ट कैरेक्टर सेम हो, है ना. So means if for some index this part and this part is same, like अगर 2 pointers लगाओगे, I को अगर इधर से स्टार्ट करे, J को इधर से स्टार्ट करे, और तुम तब तक मतलब उनको क्लोज लाते जाओगे जब तक तुम्हें सेम मिलता जा रहा है, तो तुम्हें पैलिंड्रोमिक स्ट्रिंग ही मिलेगा. ओके, ये पार्ट क्लियर है. लाइक अगर तुम A से स्टार्ट करो, इस डायरेक्शन से भी A लो, फिर इसके बाद अगर B लो, इसमें भी B लो, फिर C को कंपेयर करो, यहाँ से भी C मिल रहा है, लेकिन अगर नेक्स्ट कैरेक्टर तुम कंपेयर करोगे D और इधर E, यहाँ पे डिफरेंस है. ओके, तो तुम कह सकते हो कि एटलीस्ट ये ABC और CB ये तो हमारा होगा ही, है ना. जो A स्ट्रिंग है प्रीफिक्स वाला,
हाँ,
उसमें
सर.
ABC होगा, और जो सफिक्स है उसमें CB ये तो होगा ही एटलीस्ट, और भी हो सकता है, इतना तो होगा ही एटलीस्ट.
हाँ सर, ये जितना कॉमन पार्ट है उसको हटा देंगे स्ट्रिंग से, फिर बाकी का स्ट्रिंग में लॉन्गेस्ट पैलिंड्रोम निकाल लेंगे.
अब बाकी देखो, बाकी चीज क्या है, जो बाकी पार्ट बचा, ये वाला जो पार्ट है, अब इसमें से तुम्हारे पास दोनों में तो तुम ले नहीं सकते, ठीक है, बिकॉज मिसमैच हो रहा है इसका फर्स्ट और इसका लास्ट. सो अब क्या करना है, तुम्हें पूरा जो पार्ट है, या तो इससे पूरा प्रीफिक्स लेके A में डाल दो, या तो इससे पूरा प्रीफिक्स लेके B, पूरा सफिक्स लेके B में डाल दो, ठीक है. और तुम प्रीफिक्स और सफिक्स वही ले सकते हो जो पैलिंड्रोम है, बिकॉज अभी तक का जो हमारे पास मिल रहा है पैलिंड्रोम है, और बीच वाला पार्ट अगर हमें मैच करवाना है पैलिंड्रोमिक के साथ, तो वो खुद एक पैलिंड्रोम होना चाहिए, है ना. सो DFDCE ये जो पार्ट है, इसमें से अगर तुम A में ऐड करना चाहते हो कोई पार्ट, तो फिर वो पैलिंड्रोमिक प्रीफिक्स होना चाहिए, और अगर B में ऐड करना चाहते हो तो पैलिंड्रोमिक सफिक्स होना चाहिए. This part you are getting?
Yes, sir.
Yes.
ठीक है. सो बेसिकली प्रॉब्लम वही अभी वही कन्वर्ट हो गया. तुम्हें लेंथ ऑफ लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स निकालना है, और अगर तुम रिवर्स कर दो स्ट्रिंग को, और अगर सेम प्रॉब्लम सॉल्व करो रिवर्स करके, अगर लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स निकालो, दैट विल बी इक्वल टू द लॉन्गेस्ट पैलिंड्रोमिक सफिक्स. ओके, इज दिस पार्ट क्लियर?
Yes, sir.
Yes.
Yes, sir.
I guess then problem clear हो गया होगा. So let's try to code this thing. So let me just maintain 2 pointers P and Q for the first part. So P is 0, Q is n-1. This is the basically we are trying to add, and this is 2 strings, string A comma B. Now y P is less than Q, or let's say equal to, okay, let it be less than Q. Okay, while P is less than Q, we will be checking last character from the the ith character from the if that is equal to the pth character from the end, then we can say that इसको include किया जा सकता है. So if s of p equals s of q, then what we are going to do, we are going to add this to a, मतलब p वाला जो है वो a में ऐड करेंगे और b में q वाला ऐड करेंगे. After this, as long as this is holding true, ये हमें a में abc दे देगा और b में cba देगा, but in reverse manner. Okay, b में भी मतलब abc आएगा, but that is actually cb in reverse manner. हम उसको बाद में लास्ट में रिवर्स कर सकते हैं. ठीक है. Now the next part is ये बीच से निकालना longest palindromic prefix or suffix. So for that what you will do, like you will just call the function. Okay, let's say int some variable, let's say x equal to longest palindromic prefix. So longest palindromic prefix of what? S dot substring. What should be the like the boundaries? So पहला boundary जो होगा that should be a, मतलब कि a से start होगा, and the length that should be I think n minus 2 into a. इतने substring पे हमें निकालना है longest palindromic prefix. All right. और let's say तुमने इसको store कर लिया, string d is equal to, ये पार्ट तुमने स्टोर कर लिया, और फिर हम क्या करेंगे, इसी को रिवर्स कर देंगे. सो रिवर्स t डॉट बिगिन t डॉट एंड, stl फंक्शन यू कैन यूज टू रिवर्स द स्ट्रिंग. और फिर हम y पे भी लॉन्गेस्ट पैलिंड्रोमिक प्रीफिक्स निकालेंगे t का. So अभी ये क्या देगा, this longest palindromic prefix of the reverse string will be equal to longest palindromic suffix. और फिर we will compare if x is greater than y. So if that is the case, we will add a plus equal to s dot substring a comma 0. ये simply add कर सकते हैं. else क्या करेंगे, हम b में add करेंगे. b में क्या ऐड करना चाहिए हमें, t से जो अभी t जो है हमारा ये पार्ट बीच वाला पार्ट स्टोर कर रहा था और हमने इसको रिवर्स कर दिया. सो बेसिकली हमें t डॉट सबस्ट्रिंग 0 कॉमा y ये पार्ट ऐड करना होगा. और फिर इसके बाद हम एंड में रिवर्स कर देंगे b को, बिकॉज b हम उल्टे डायरेक्शन में हमेशा ऐड कर रहे हैं. सो हमें इसको भी रिवर्स करना होगा. रिवर्स b डॉट बिगिन b डॉट एंड, एंड देन वी विल प्रिंट स्ट्रिंग आंसर इक्वल टू a plus b. Okay, so is this problem clear to everyone? Like just tell me if it's clear or not. Okay, so I think that's all for the KMP and prefix function part. Like there are many other standard problems. I have given you the link for CP algorithms. Like go through that article, you will find many other standard problem applications of prefix function. Try to go through all of them. And like prefix function, you also have something called a Z function. So that also you can like go through it. It is like a it is also something like similar to prefix function, but it is something different. Okay. So Z function भी एक बार देख लेना. And we should move to the next part, I think. So Ritik. Yeah. Am I audible?
Yes, sir.
Yes, sir.
It's here. So is my screen visible?
Yes, sir.
So our next topic is try. Before starting try, let me ask you one question. Suppose you are given a number of strings. Suppose you are given n strings, and after that you are given some queries. Suppose q queries are given, and you are asked in each query that whether the string, whether the prefix of that string is present in the given array or not. Like suppose in one of the query, suppose ABC is given, then you have to find that whether ABC is a prefix of any of these string or not. So did you get the question? Like there are n strings, and you have to check whether that the given query string is present as a prefix of any of the n strings or not. So how you will do this question? Like basic brute force approach. What would be the brute force approach?
So mapping.
For
Uh,
each string, we will check that ABC is a substring or not.
yeah. So like you will go through every of this string and you will check that whether the prefix matches with this string or not, isn't it?
Yes, sir.
So what will be the time complexity in that?
NQ and length of the substring.
Yeah. Q into, suppose m is the length of the string, maximum length present in the among the n string. Okay. So this will be the time complexity. Now this is pretty high complexity, because suppose queries is too much and n is too much, then of course like n and q both are around 10 to the power 5. Then in that case, this would be very much high. Okay. So now other things, you can see that we are only requiring the prefix of something. So how we can manage to optimize it? Like for A, we do not need to take care for all the letters. We just need to take care for the A. The string is starting with the A. Can you see something like this? Like for we are only checking for the prefix. So if we somehow divide all the n strings into buckets, like one which start with A, one which start with some other character, then again there is a bucket for one which starts with A, and then there is bucket for one which starts with B, similarly for A. So if that is present, then how many what would be the time complexity to find the string? Like suppose if you are given the bucket of all the n strings are divided into such that A bucket is there and B bucket. So there are like several bucket starting with the character A. In this bucket also you are given the one starting with the second character is starting with A and the B. Like suppose this type of structure is formed. Like we are having all those string which are starting with A will be present in this bucket. All those which are starting with A and B are present in this bucket. All those which are starting with A
and C are present in this bucket, and suppose this is for the B, all which are starting with B, and suppose BA are present in this bucket. So this is like a tree type of a structure is there, and in each bucket, in each of the node represents some of the prefix of the string. Okay. Are you getting what this tree is looking like?
Yes, sir.
Okay. So like these were the string. If we suppose these are the n strings, then we will try to form this type of a structure. There is one node which will represent the empty string, that is nothing. Then we have one node for all those which will be starting with A will be kept in this as children of this node. Okay. All those which are starting with B will be kept in this as subtree of this node. All which are starting with C will be kept in this as subtree of this node, and similarly for all other letters. Okay. Here for A, we could have it starting with AA, or we could have AB. Similarly, continuing in this way. Okay. For B, similarly, we can have BA, BB, and for C also, suppose we are having CA, CB, CC, CD. Okay. And again, this will continue for every node. We are having like bucket for every of the characters. So how much time you will require for searching? If suppose you have this structure, then how much time it will require to search any of this string?
O of n.
O of m, yeah, the length of that string. You will
Yes.
simply traverse the character which you require. You will go to that node. Like suppose if ABC is required, we go to A, then we go to AB, and then we go to ABC. Okay. So the time complexity would be order of m. Okay. Now, how many nodes will be required to represent this graph?
At max 520.
Max and nodes, sir.
At max,
And
n
nodes.
m node.
Yes.
If and nm nodes would be required. A little bit greater than nm nodes, because for every node we are assuming like A, B, C, D, E, F, G, H, like up to Z. For this node, so we are considering AA and up to 26 nodes. Okay. Even if AA is not present among the n strings, then also we are considering. So even if we are having 26 nodes with every of these nodes, then also it will be at max nm into 26, isn't it?
Yes, we can say all leaf node will be summation of all n lengths. In worst case, we will represent all the n string with different one. So I'm saying that in worst case, we will represent all the string with other leaf node.
Yeah. Yeah, in the worst case, but in that case also, the the space complexity which you will require would be like n into m, because n strings are there, and maximum length we are considering m. Okay,
Yes, sir. Yes.
and for each node we are also considering 26 letters. If we suppose keep for every node all of its child representing each of the character. Okay.
Yes, sir.
Okay. So now for each of the query we would be requiring 2 into m time complexity. So you can see the if the constants were like this, n comma q is less than equal to 10 to the power 5, and n into m is less than equal to 10 to the power 5, then in this case this complexity would not have run, but this complexity would um, will be pretty much fast, isn't it?
Yes, sir.
Okay. So now how we will represent this graph? One way is simply you can use like adjacency matrix as you do for the simple graph, but you will have to take care for every of the nodes, like you will have to do numbering 1 2 3 for each of the nodes, and it will be pretty much complex in that case. Okay. So for representing this tree, which is also known as trie. So trie is nothing but a tree like a structure in which every of the node represents the prefix of the string present in the database. Like we are considering all these elements as database. Suppose we call this as database. Then trie is a structure storing a database in form of a tree where every node represents some prefix of present in the database. Okay. So like if you start from the root and go to that node, then it will represent some prefix which is present in the database. And so in so the we have seen that the time complexity of that space complexity of that trie would be maximum n into m into 26, and maximum length of maximum height of that tree could be m. Okay. So now let's see how we can do it in C++ code. So let me give you one question which is just similar to this question. So I have pasted it in the link also in the chat. So is it visible? Contacts problem.
Yes.
Yeah, so this problem is similar to that problem. You are given a number of queries in which you are adding some word to the database, and you want to find some partial, which is just the prefix of any of the string present in the database. So you have to just find out how many times it has occurred. So like in the trie only, if we just store that how many of these occurrences have been occurring, like for a, that would be just the subtree count, isn't it? Like for a the count of all the nodes present in below it will be the number of strings which are present in which are having prefix as a. So if we just have additional information about the number of nodes present in the database starting with A, then we can simply print the answer for that case also. Okay. So let me just code it, and then you will see. So for representing each node, we use a structure. Structure is a special kind of type in which you can have several other. It is like a class where you can have several different primitive data members or non-primitive data members. Okay. It is just like some encapsulation for other data. Okay. So suppose this node represents the nodes which we are referring to, and then there we will keep children. 26 children would be there. Okay. Now node start. Do you know what is node start? This pointer thing. Have you read about pointer?
Yes, sir. Self-referential point.
Yeah. So node pointer. So pointer is basically address of some data. Okay. You can read about pointer later on, but for now you only require to know that it is just pointing to some other data. It is just storing the address of some type node. Okay. So like here, if we have we will be having address of each of these nodes in the child of A. Okay. For each of the nodes. Okay. And now the constructor. So constructor, you know now what is constructor? So even if you don't know, you may go through this thing. It is basically the initialization of any of the structure. Like whenever a structure is formed, then it will use the code inside this to have its initial representation. Okay. So at the beginning, if any of the node is formed, then we know that it do not have any children. Okay. Like if suppose D is there, when we form that D, there are no children because we have not added anything, any string starting with the prefix D. So in that case, we simply denote it with null pointer. Okay. So this will represent, this is similar to the graph. We are just representing it with the structure. In this case, we do not require to check for the numbers. Like otherwise, you would have to do some mapping to these numbers so that you can easily show them in the graph. Okay. Now we have t-test cases. We have some query with the word. So we have two type of query, add and find. So let us first make another function for adding any new string to the graph. Okay. So this function will add the string to the graph. We will pass the root node. Root node is this node, which is representing the empty node. And then we will pass the string. Okay. Now, the way we will insert it would be like this. We will check for every. We will start with the iteration of that word, and we will check if if the temporary variable on which we are, suppose we are on some variable, some node, suppose it is b, then we will check what is the next letter in the string. If that is present at this child, in that case, if si minus a, this will be the index of the that letter. If that is present as the root, then it will not be equal to null pointer. In that case, we will just simply move to that node. Okay. Otherwise, if it is not present, then we will make a new node. So this thing, new node, is important thing. This will allocate the memory for the node, and we are just assigning the value of that address to the child of this present root node. Okay. So this also you can refer to the pointers. Like if you study about the pointers, then you will find that new node, there is special keyword for new and delete, which are present for the pointers. With the help of new, you can allocate the new memory, and with the help of delete, you can delete any memory. Okay. So we just only require to know here is that we if the current node is not having any such character, then we are just allocating new space for it, and we are assigning that new node with this thing. Okay. And then we will simply move to that node. So insert operation is clear.
So that first if condition is not required, I think. Means if B doesn't do that, then what?
Yeah, here we are checking it because suppose if you do
So
not check it, then
if it is null,
whenever,
then so if it is null, then we can give a new node. If it's not null, then we have to do nothing.
yeah, like suppose in between of the operations, you have already inserted some of the nodes. Like suppose I have only inserted AB. Now, like currently we have only AB present in the database. Okay.
Yes, sir.
Now we are inserting, suppose A, B, C. So if we are inserting A, B, C, then we are doing it like this. At the root node, we check if there is a node present with A. It is present there.
Yes, sir.
So we move to root of A.
Yes, sir.
It is present. So we will simply assign root equal to root child of S minus A. So we will go to here. Okay.
Yes, sir. Got it.
After AB, now we will check for AB. B is present there. This node is representing B. Okay. Like this age is representing B. This age is representing A. Okay.
Yes, sir. समझ गए.
After that, we will go to C. Because C is not present already, we are using new node here.
So we will use new.
Okay. Because C was not already present there. So we are creating new. If you are not creating and you simply assign, then it will result in runtime error. Okay.
Yes, sir.
So you always have to check that whether the node which you are using is present or not. Okay. Now, one more information we require is that how many times it is present. So for that, so we can keep another variable here, int frequency. Okay. And we will initialize initially it with 0. this will represent how many times this node is occurring in the database. Okay, how many time prefix of this string is present in the database. Okay, for that also we can simply change it here like this: root of child of s of I minus a. Sorry.
Excuse me, sir.
Yeah.
Sir, can you again tell what does frequency store?
Frequency stores like this: how many times a string prefix is present in the database. Okay, so like for any node, if we consider the prefix starting from the root to this one, then how many times this is present in the database.
Yes, sir.
So like whenever you are inserting, then for whatever node which you are visiting, you are just increasing the count of frequency there. Like the letters, whatever letters are present in SI, whenever we are reaching that node, we are just increasing the frequency of that node. Okay.
Okay, sir.
It might be a little bit confusing if you are not knowing a structure and new node or the point about the pointers. Okay, but you do not care much about the pointers thing. You only think that if this is not present, we are just creating new pointer for it and we are storing it, and for whatever node which we are visiting, we are just increasing the frequency of that node. Okay, now the another operation we have to find is the find operation, which is just the number of times it is occurring. Okay, so here also we will be requiring the node, the starting root node and the string. Okay, now how should we go in this question? This is very much similar to the insert operation. So what we should take here? Suppose you are at root and you are given the string s. So
If not present, then return 0.
yeah, if we will check simply if root child of s of I minus a, if this is not equal to null pointer, then it will return true, and in that case we can simply move to that node because that is present.
Yes, sir.
So we will simply go down in the tree using that branch. Okay, otherwise if it is not present, then we know that no such word is present in the database. Okay, in that case we will simply return 0, because if it is empty, if it is null pointer, then there is no word present with that prefix in the database, so we will return the frequency, which is 0. Otherwise, after going through all the letters, we will be at the correct node, which will be representing the prefix. In that
Root
case,
frequency.
what will be
Root
returning?
frequency.
Yeah, root frequency. One more thing I didn't talk about this point, this new operator. If you are not knowing pointer, this is simply for dereferencing any member of data structure. Frequency is a member of node structure. Child is a member of node structure. So whenever you require to find the value of it, you use this arrow operator. Okay.
Excuse me, sir.
Yeah.
Sir, what if we do not use new? Then will it work?
No, if you do not use new, then how you will do? Can you tell?
So we will just initialize as root root arrow child SOI minus a is equals to node of then brackets.
Okay. You are saying like this one node, isn't it?
Yes, yes.
So when you call the constructor like this, then it returns the object of that class. Okay. And when we use the new operator, then it returns the address of that class. Okay. So
Okay.
like if you read about the pointers, then you will come to know that there is something object, there is class, then there is pointer. Object is like the exactly the value of that class, but pointer is the address of that value, that where it is present in the memory. Okay.
Okay, sir.
So and here we are here the type of child we are taking is node star. So node star is a pointer, so we have to take new node. Okay.
Okay, sir.
It would be better if you do some of the implementation for the pointers, because pointers is important not only for this topic, for the linked list also, which will be asked a lot in interview questions. Okay. So we have the both the operations. Now here also we have nowhere initialized the our empty string. Empty string means this starting the root node. So for that also we have to allocate memory. So we will do it here. Node star root equals to new node. So this will be the root of the our database. Now here we will simply do the operation insert. We will pass root and word, and for the find we will print root with the word. Okay. So let's run the code. Okay. So the code is clear.
Yes, sir.
Um, if it is if even if it is not clear, you just go through the pointers. You work on the pointers, because the main point where you will be stuck here is the pointers. What is new and what is a pointer, what they represent. Okay. Otherwise, the code is very simple. It is just like traversing the graph. The way you do in the tree, we are doing just that thing. Okay. Let me paste the code here. And this type of problem is often asked as a hard problem in like in interview questions. Either it could be in interview, or it could be in test also. Okay, like for the Google, Amazon, they mostly ask question from Trie or Sprinkler. Okay. Uh, Another type of question is let me ask you this question. Let me answer. Uh, So in this question, you are given an array of integers of size n, and you have to just find the minimums of any two elements. So the what would be the basic approach, the brute force approach?
So that will be n square and
N square.
Yeah, that would be the n square. So can you think of any optimized approach for this problem?
if we see numbers in binary,
Yeah.
then if we have two prefix matches, then it will be.
Two prefix matches what? So
Yes,
like suppose we have numbers 5, 7, 9. So we represent them as binary. Suppose our maximum bits length is 4. In that case, so these will be the string, binary string.
yes, sir.
So what you will do with this binary strings?
So, so our target will be like greedy, that maximum bit should be 0 in the final answer.
Not the maximum bit should be fine. Should be 0 in final answer. Our objective should be to keep all the bits 0 which are having higher value. Like we would want something to be 0 here, something to be 0 here. So we have to give the priority for our prefix of all these things.
Yes, sir, I am saying that only. Sir, I am saying the most significant bit should be 0.
Yeah. So the question is like, if we can make the most significant bit to be 0, then we should always try to do it. If it is not present, then we have to choose the other character.
Yes, sir.
But if it is present, then we always try to choose it such that it becomes 0 for the MSB. Similarly, we go uh, through the other bits. Okay. So we can like this could be represented as a string, and if we form the trie over these strings, then the trie would be looking like this. There would be one root node, there would be only two child, 1, 0. Okay.
Yes, sir.
0 would represent all the subtree, all the strings which started with 0 bit, and 1 will represent all the strings which start with 1 bit. Similarly for other cases. Okay. So suppose we want to minimize here. So how we will traverse such that we will minimize? We start from here. Suppose our string is 0, 1. And suppose this is not present. Okay. Suppose the trie we have formed is like this, and we are checking for the string 0, 1, and we want to minimize. How we will traverse? We start with here. To which direction we will go?
So, right direction.
Yeah. because 0 is present there, it is not null. So we would always try to minimize. In that case, we will choose the MSB to be 0 here. If it could be, then we will choose this one. Okay. Now we try to choose 1, but 1 is not present as our child. Okay. So in that case, we are like forced to choose 0 in that case. Okay.
Yes.
So that way we will traverse in our try. Okay. So I'm not writing the code as of now. I would like you to implement the code
Yes, sir.
so that we can see tomorrow. Okay. We will be implementing the code tomorrow. Okay. But you try to implement this code. There is one more problem associated with this minimum XOR. We will also go through it tomorrow. Okay.
Okay.
Try to implement it. Okay. Okay. If there is any other doubt, then you may ask. Otherwise, you may leave.
Thank you, sir.
Thank you, sir.
Thank you, sir.